GMAT all day.
For the final problem in our absolute value series, let's take a look at a complicated absolute value problem where we're going to have to combine our algebra absolute value skills with our testing number skills, along with just some old-fashioned logic. And that is really how I approach most GMAT questions. In other words, if you were to see me do the same GMAT problem 3 times, you would probably notice that I do it a bit differently every time, because I do not memorize just a single approach for doing any given problem. I just have a framework, and so you should expect it to be done a little bit differently every time. And oftentimes I can do algebra to simplify or rephrase a question so that it's easier to test numbers in order to get the final answer. Or sometimes the reverse is true. Sometimes when testing numbers, I can then see the underlying algebraic principle, which makes the statement sufficient or insufficient. And that is just as good as if I had done the actual algebra. So this question says, if x is not equal to 0, is the absolute value of x less than 1? And so one thing that is different about this problem than some of our other ones is I can do some work on my prompt here up front. I can get rid of my absolute value sign here. I can rephrase this question, put it just in terms of x. And so this question is asking, is x between -1 and 1? And I like that a little bit more, because now it is almost as if we don't even have an absolute value question anymore. So I am happy. But then I look at my statements, and once again, I am sad, because it looks like we have absolute value expressions in both of our statements. So statement 1 says the absolute value of x over x is less than -1/4 times the absolute value of x. So is there anything I can do here to simplify this statement? And so I cannot multiply each side by x. So if I want to get rid of my fraction here, for example, and the reason for that is, so I know x is not equal to 0, but I have an inequality here. And so that means I also have to know something about the sign of x if I wanted to multiply each side by it, and I don't. And so I cannot do that. However, since x cannot be equal to 0, what that means is the absolute value of x must always be greater than 0, and therefore I know the sign of the absolute value of x. And so, in fact, if I wanted to divide each side by the absolute value of x, I can do that. And if I did that, that would actually cancel out my absolute value expressions. And that would just leave me with 1 over x is less than -1/4. So this is a much simpler inequality. And if I wanted to test numbers the rest of the way by setting up a table, I can do that. And so set up our table. What do we need here? So we're going to need an x. We're going to need a 1 over x. And we got to make sure that 1 over x is less than -1/4. So I'll put that in the table as well. Then we got to answer our question. Is x between -1 and 1? So for my first example, I just want to come up with anything that fits my statement. And so -2 looks like a good place to start. Because if x is equal to -2, 1 over x is -1/2, and -1/2 is less than -1/4. So this works. Then I got to answer my question. Is x between -1 and 1? And so -2 is outside of my range. And so this is a no to my question. Now it is the second example that I have to put a little bit more thought into it. Here, I would not want to choose, for example, -3, even though it might seem like a easy number to come up with, because -3 is another number outside my range. And so that's just going to give me another no. I am now actively trying to get a yes. And so I should want to choose a number within my range. And so one thing I might notice now is, okay, so if the left side has to be less than -1/4, that means the left side has to be negative. And that means x has to be negative, because I cannot change the sign at all of my numerator here. So if x has to be negative, I really want to be choosing a negative fraction here, because it has to be something within the range. And so I'll try -1/2. And that actually looks good, because 1 over -1/2 gives me -2, which is less than -1/4. And now I have a yes to my question, which makes me good to say that I have proven insufficiency for statement 1. statement 2 says x over the absolute value of x is less than x. So anything here we can do to simplify this statement. And so I cannot divide each side by x because, again, I don't know the sign of x here. I can, though. I can multiply each side by the absolute value of x if I want to get rid of my fraction on my left side. And I think I will do that just because I prefer not work with fractions if I don't have to. So x is less than x times the absolute value of x. And now if I wanted to continue testing numbers, I can. And so what do I need here? I'm going to need an x. I'm going to need x times the absolute value of x. And I need to answer my question. So what's an easy example that I can start with here? And so you can sort of forget about this because we rephrased the statement here, and it looks like 2 should be a good place to start because it looks like, so for a positive integer here, you're always going to have a greater number on the right side because you're multiplying that integer by itself. If x is 2, 2 times the absolute value of 2 is just 4. And so 4 is greater than 2. And to answer my question, is x between a negative 1 and 1? And that is a no. Now I'm trying to get a yes. So we want to only be testing numbers within our range. And so what if I tried x is equal to 1/2? Then x times the absolute value of x would be 1/4. So this does not work, though, because this does not fit the criteria of our statement. 1/4 is not greater than 1/2. So what about negative 1/2? Because that is also within our range and would give me a yes. Negative 1/2 times positive 1/2 is negative 1/4, and negative 1/4 is greater than negative 1/2. So this is good. And now I have a yes. So that is good to prove my second statement insufficient. And so now my brain is a little bit fried, but I still have to look at my statements together. But that is why we did our problem in a very organized way, because I don't want to have to be coming up with entirely new examples. I want to be reusing as many of the examples as we can. And so it looks like statements 1 and 2, we both used negative 1/2 as an example for x. So we should be able to reuse it when looking at our statements together. And so we are starting with a yes, and now we are actually just trying to get a no to our question. So to start, I might say, can I reuse this negative 2 from my first example in my second example? So negative 2 is positive 2 is negative 4, and so it looks like that would not work because that would not be greater than negative 2. What about, can I reuse the 2 that I used here in my first statement? And I can't, because it looks like in my first statement, x always has to be negative. I think we said that before. So if x has to be negative, and remember, I'm looking for a negative integer because I'm looking for something outside my range here, I can actually now sort of see that I will never be able to get a no to my question here, because x can never be greater than 1, because from my first statement, x always has to be negative. And then it looks like from my second statement, x will never be able to be less than negative 1, because in that case, I'm always multiplying a negative number by a positive number that is by a positive number that's greater than 1. And so that number is going to be getting more negative. So if I'm comparing it to x, I'm comparing x to a number more negative than itself. And therefore, I'm not going to be able to get a no here. My only values that will work will be values that are within this range. And based on that, x will always be within my range. And therefore, together, my statements must be sufficient. The answer is C. So that is it for our absolute value series. Not the highest yield topic, but you definitely will see a few absolute value questions. So just know how to approach them in a organized fashion. And I will see you in the next video series.